These are not our slides per se. I've taken them from guys like John Holdren, President's Science Advisor, guys like Dr. Ralph Cicerone, President of the National Academy of Sciences. You know, they're pretty well respected. The other thing that these particular slides are is they are not forecasts. So it kind of gets away from, well, geez, the models are this or the models are that. They're really observations. And the top left, you can see when you start looking at long-term trends there, and by long-term I'm talking about a 5-year average, that the rate of global heating has in fact not appreciably slowed down. It's continued. Sometimes you hear about, well, the hottest year was 1998, so you know, why are we worrying about this? And again, depending on the exact data source, some folks think 2005 was the hottest. Others say 2005 was just missed 98 by a smidge there. Anyways, we still see the long-term trend is coming up. Just for fun, I put the solar irradiance down on the lower left because I'll tell you, if I had a dime for everybody who's come up to me after various talks in various places and said, hey, Titley, it's all about the solar cycles. What don't you guys get about that? I could be rich, but I wouldn't be rich with a 1.0 correlation in those two charts. It's just not really there. The second, or the middle view of graphs there, and then I apologize, it's a little tough to see in this room here. This is something John Holdren showed at Copenhagen, and the colors show the type of ice it is, where green is the older ice, and by older I mean more than 2-year-old. That sort of bluish color is the second-year-old ice, and the purple color is like first year. So you can see what the averages are in the top left. And then you can go to 2007, 8, and 9. I think most people know that 07 had the least, at the ice minimum in early September, had the least amount of coverage. And yes, there has been come back in 2008 and 2009. When I talk about how much it's come back, it's like, you know, if you wanted an analogy, take a look at your 401k now versus like a year ago. That's kind of like how it's come back. It's sort of this flat cap bounce. The part that, sorry, Ron, the part that is interesting, what has not come back, and again, I apologize, it's a little tough to see in here, is if you look at 2007 and then just go down to 2009, you'll see that there's much, much less green. So if you look at ice volume, the ice volume is reaching a record low in each one of these years. So we're really seeing a tremendous change in the Arctic. And I think this is one of the parts, I know AMS is going to be talking about communication this coming year, and I think that's an absolutely fantastic topic to really concentrate on because, you know, climate is big and people sometimes think, geez, we're so small, how can we possibly make an impact? Well, one of the things climate is very unstable. You may not think that, but it's really unstable. And what we're seeing is kind of a change, and I'll use this analogy for this audience here, is kind of normal modes, if you will, and we're going into another normal mode. We're going from an Arctic that was like pretty much frozen pretty much all the year round into one that will freeze back in the wintertime for decades and decades to come, and it's going to probably melt back to nearly ice-free in the late summer and early fall. So you sort of get this quenching and very, very dynamic kind of Arctic. That's a very different regime that any of us have grown up in, or that when we think about national security that any of us have thought about. So that's just something that's coming up. Top right graph, this is simply showing how the rate of ice coming off of Greenland is accelerating. And I see Susan Avery from President and Director of Woods Hole is in the audience. Some of her researchers have done just tremendous work in the last year or two. And what they have shown is that the water getting into the fjords is actually about 1 to 2 degrees Celsius warmer than we've previously seen. So what? Well, it turns out that about 1 to 2 Celsius melts 10 to 20 meters of ice off the bottom of these glaciers that are coming down from the ice fields. The glaciers had been grounded on the seafloor, and if you want to kind of think of an example of what does that mean, go look at a medieval cathedral or the National Cathedral in D.C. When you see those flying buttresses, and they tend to keep the walls from spreading out, Well, now those buttresses aren't touching the ground, those glaciers aren't, so the ice is coming out. IPCC didn't account for that dynamic at all, and that's what Jay kind of talked about. So when I talk about climate change, I talk about 1 to 2 meters of sea level rise. Now, I've had a couple people say, well, why does the Navy care? And it's like, well, we tend to build our bases at sea level. That's one reason, if you think about it. So, you know, we really need to go and think through which bases are defendable, how do you defend them, which bases are not. But there are additional components to that besides just U.S. infrastructure. Think about Diego Garcia. Think about how much logistics and what a support base that is with all but unfettered access and use for whatever the Department of Defense wants on that British territory. If that goes away, what force structure is required so that the DoD can meet its missions? What is the political military structure of the South China Sea if the Paracels and Spratlys go underwater with all the disputed claims? Are those claims still valid? Are they not valid? Will everybody recognize them? What's the governance regime for there? So those are just some things. Copenhagen, you can see kind of, this is, let me just stress, these are personal observations. I was part of the U.S. delegation. I was not part of the negotiating team, and I was only there for about 24 hours. So this is like a snail's eye view of 24 hours of Copenhagen. 15,000 people, about another 25,000 people trying to get in to be with the 15,000. It was interesting. It was interesting what was and was not talked about. You can see my takeaway, it's about the money. It was not about the science there. I think I might push back a little bit on Ron saying that the science is not for debate. I would say in most of the world that's true. I'm not sure that's true in the United States. But most of the world that is true, and that really wasn't the issue. The issue was how much money was going to move between the developed countries and the developing countries. So that was, but it was certainly interesting. Why does the Navy care? You can kind of read through some of these, and really what we are looking at is kind of some more specifics to kind of flesh out both the CNA study as well as General Engel's National Intelligence Council study. Near term, in addition to the challenges we're going to have with the Arctic, frankly, there are some tremendous partnership opportunities. General mentioned that the Arctic Council is looking, you know, for, or the nations are looking for cooperation. UN Convention on the Law of the Sea is the governance regime. This is not the Antarctic. There is no appetite for a unique treaty. Somebody said, you know, if you want to think of the difference between Antarctica and the Arctic, it's people, not penguins. So that's one way to think about it. It's also an ocean surrounded by land rather than the other way around. Partnership opportunities, I'll just give you one example of what we're working within the U.S. government. We have a tremendous opportunity of the Department of Defense working with Commerce and NOAA and the Department of Energy and some others to really put together a 21st century coupled air, ocean, ice forecasting system. And my challenge to the scientific community is I want 0 to 30. And by that I mean 0 hours to 30 years. We have to have a seamless way to do this. There are some very significant scientific challenges to do that, but that's what we need. You can read some of the wild cards. Acidification. If somebody asked me what keeps me up at night, ocean acidification. We understand the science of how that works, but the question is can the ecosystem adapt as fast as we are changing the ocean? If it can't, you've got to start asking yourself, where do the 1 billion people who get their protein from the ocean, where are they going to get it? Change the southwest monsoon, change the very significant agriculture in southwest or in Asia, in China, in India. How does Russia play into that? Tremendous national security implications. Let me just close here very quickly. You can read these parts, but as was mentioned, I run Task Force Climate Change. My colleague and counterpart, Admiral Phil Cullum, runs Task Force Energy. The Navy is very, very interested in a capstone goal set by our Secretary of the Navy, Ray Mabus, to reduce our carbon-based energy by 50% by the year 2020. That is more than a stretch goal. That is a real, that's out there. But that is exactly what we've been asked to do. And we're asked to do that because we need the mobility. We need the tactical flexibility that efficiency will give us. We also, frankly, need to reduce our strategic dependence of sending a lot of money over to folks who don't necessarily have our best interest at heart. Oh, by the way, that also reduces significantly the Navy's carbon footprint. I'll just leave with two things here. When we talk about some of the mitigation at Task Force Energy, some people will tell me, well, even if the Navy went to zero, how's that possibly going to change the world? And just like everybody here who's a physical scientist know, there's many, many nonlinear impacts and implications to climate change. I also argue that leadership is nonlinear, and a little bit of leadership in the right place can have tremendous results. The other part I talk about, especially when to the folks wearing uniform, is we're all familiar with the acronym C2. We usually think of its command and control. I would argue it's also communication and collaboration, because that is how we are going to collectively solve this problem through adaptation and mitigation. Thank you very much.